Hello, welcome back. So our lesson on hyperbolas is going to be split into two parts, and this is just the first part. We're going to introduce you to what a hyperbola is, the formula for it in the conic section unit. There's going to be some more vocabulary, of course. A lot of it is going to feel similar to what we just learned with ellipses and the other conics, but one of the major challenges now that we're going to see our last conic is if I give you a general conic form equation, can you do some manipulation to it to figure out what you're looking at? Is it a hyperbola, a circle, a parabola, an ellipse? So that's going to be the grand finale of this of this fun. All right, it did say the pink reference sheet. If you're looking at if this is one of my students looking at this lesson, you are going to be looking for, I think it's a green reference sheet, not pink. All right, so I'm a little tight on time for this lesson recording. I'm going to skip through some of these slides, but what we have, I love this picture, this diagram of showing what a conic is. And we've discussed parabola, circle, and ellipse. Those are over on the left side there. But now we're going to see what happens when this sheet of paper we talked about, this plane, intersects the cones like such, and you end up with what's called a hyperbola. And just like with our other conics, we're going to have vertical and horizontal hyperbolas. So this is a nice diagram for what's really going on in a hyperbola. And you're going to see some more vocabulary and some similar vocabulary. So there's still going to be focus points and foci, and there's technically a center of the hyperbola, although it's not actually on the branches of the hyperbola. It's a little confusing. We'll talk about that in a minute. But there's a relationship between the distances that they've marked here in red and in blue, just like there's a relationship between the distance of any focal point and the conic itself. So you don't have to get bogged down by why the formula works at this point, guys. I just need you to know what it is. Some more vocabulary. This is a little new. We have transverse and conjugate axes this time. Basically, they end up with asymptotes, these oblique-looking asymptotes that are going to create the shape of the hyperbola, the curve. It's not as complicated as it seems right now, I promise. When we go to graph these, though, I need all the help I can get, right? So I'm going to be graphing all the vertices that I can find. I'm going to graph this weird little rectangle, auxiliary rectangle in the middle. That's going to help. The equations of the asymptotes, I don't want you to panic about that. It's actually just a point slope form of a line, and everything you see here is on your formula sheet. So there's no need to memorize anything. Oh, this is Hofbauer, my counterpart, put cute little smiley faces. You need to make sure that you have found all of these things that have smiley faces next to them when you're going to graph. Yay. All right, here we go. We have the standard form of a hyperbola. When you have a horizontal hyperbola, the x value is first, and then vertical, the y value is first. We kind of saw that with ellipses. Big difference in the formula, though, here is there's a subtraction sign between the two fractions instead of a plus sign, and that's what creates this very different shape from an ellipse. That's also how we're going to be able to tell whether we're looking at a hyperbola or an ellipse, or a circle or a parabola. Is one of the dead giveaways on a hyperbola is that there's a subtraction between the two quadratic fractions. Alright, and then there's a nice little formula there, a squared plus b squared equals c squared. That seems very familiar, doesn't it? Now on the ellipse, there's a little different formula, so I don't want you to confuse these, and I want you to, because you are new to these, you got to keep coming back to your formula sheet and make sure you're using the right formula, the right variation of Pythagorean theorem. It's really a distance formula question, right? Oh, you could spend all day talking about how that formula is derived. All right, so this one, they just want you to watch, all right? So hang with me here. If I'm looking at my formula sheet, and I notice that oh, for Pete's sake, nothing's worth this. This is how my day's going to go. Well, here we go. All right. Oh, man. Okay, we're back. Excuse me. They just want you to watch this one. Oh, man. Okay. I'm going to get something to work right. There we go. Now you're just going to watch me go. We have a hyperbola. Y squared minus x squared equals 1 on the end here. This is a hyperbola, and it's going to have that vertical notation to it. If I look at my formula sheet, it's the hyperbola that's going to have, everyone calls them parabolas. They're not really parabolas. So the two branches that are going vertically up or down. Let's see, I think the best way to approach this is just pluck out the information that you can see. So the center of this hyperbola is at hk, which is the easy one. It's at 0, 0. And remember, h is always with the x value, k is always with the y value. So either way, it's 0, 0 in this question. The a squared value is 9, so that means my a value is 3. And then b squared is 25, so b is 5. And then I'm going to just go ahead and do a little side formula here. A squared plus b squared equals c squared. So if I'm trying to come up with the value for c, we will be doing the square root of, this is not on your sheet, right? I hate when I do that and I work through a problem that's already done. I'm not even looking at the right sheet. There we go. Where's it at? Da, 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 da. No, we're good, we're good. It's not on your sheet. This isn't even on your notes. Alright, so definitely just watch. Alright, so a squared plus b squared equals c squared. So square rooting that, you're going to get the value of c, which is square root of 34, which is, I like to give an approximate value in case I have to plot something, which I am going to have to do. Let's see, I don't think I ever came up with that, but it's 5 point, close to 6, so 5 point, I'm just guessing here, like 8, 9, I don't know, something like that. Alright, I should have typed that in. Anywho, coming back, what we're going to do now is we're going to plot some things, and the first thing I would plot, even though it's not part of the branch, is the center at 0, 0. And then I'm going to make that auxiliary box. So the a value is under the y component, which means it's a vertical direction, okay? So up 1, 2, 3 is how far up this auxiliary box is going to go. So I'm going to kind of put a mark right here. And then down 1, 2, 3. Oh, they're counting by twos. You know how I feel about this. Alright. Okay, there's 3. There's negative 3. And what I also just happened to find, because I was on the major axis, which they don't call it that in hyperbola, I think they call it a, I forget. Anyways, we just found vertices. So vertices were at the formula, and if I use the formula, it's h for a vertical, h comma, let's see, k plus and minus the a value. So for us, that would have been 0 comma 0 plus and minus 3. So we just found out 2 vertices at 0, 0, 0, 3, excuse me, and 0, negative 3. But remember, like, if you're graphing it, you don't really have to use the formula if you can just count. Like, that's my theory. Anywho, the other thing we have to talk about is the other direction. The b value is 5 units. So counting out 5 units in the horizontal direction, that would be here and here. And what I'm going to do now is I'm going to extend these and make an auxiliary box. You have to kind of visualize where they would have began and ended. Boop, 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 boop. It helps if you make that sound effect, I find. No, kidding. Alright, there we go. Oh man, that was ugly. Okay, that's not going to be part of our hyperbola, but it is going to help me create the asymptote lines, because the asymptote lines are just going to be the diagonals cutting through this rectangle. So I'm going to go ahead and graph those in. Oh man. Can't even do that right today. It could be a rough day. Okay. Whew. So there is something else we have to find, even though it feels like, why? They're going to ask me about the focus points. So the foci on a vertical hyperbola is at the formula h comma k and then plus and minus the c value. Nope, that's not right. Back up. I always do this one wrong. Oh no, it is. Right? I don't know why this one always bamboozles me. It sure is, because it's k plus and minus c. Yeah, I'm good. Alright, so here our h was 0, and then our k was 0, but remember that c value is plus and minus the square root of 34, which is like really close to 6. So when I go to draw in my focus points, my foci, oh gosh, here's 6, huh? So it's like just under there. and then -6, like right there. And that's all I'm going to do as far as the foci. I'm not really interested in them right now. My last task is to actually draw the hyperbola itself. This is a vertical hyperbola. So this is the vertex, and this is a vertex. And you just have to make sure that it kind of scoots along the asymptote lines that you sketched in. Oh man, I nailed that. Look at me go. Oh, I shouldn't have got cocky though, because now I have to do it again. Yeah. I'm going to call that a win. That's our friend the hyperbola. It's interesting. I don't know if you're enthused by it. I like it. Alright, let's do one on your notes. Is this one of those ones that's already done for you though? I hate when that happens. Looks like, oh, you know what? Finally this one's not totally done. It's kind of half done. Alright, so we have a formula, which I have covered. Let me move it. There we go. So we have another similar hyperbola. We have a vertical hyperbola here. The y value is first. So that tells me a few things, and I think they marked them here. A squared is 16, so that means a is 4. And b squared is 4, so that means b is 2. So if we do a quick calculation for c, c is the square root of a squared plus b squared. So that would be the square root of 20, which of course you can reduce to, let's see, 2 square roots of 5, or I think I wrote down, like it's roughly 4.47. I just think it makes, I know it's prettier to look at 2 square roots of 5, but 4.47 if I'm going to graph makes a lot more sense to me. Alright, so the center is at hk, which is still at 0, 0 in this problem, so very similar. For this vertical hyperbola, the vertices are at h, k plus or minus a. So for us, that would be at 0, 0, plus and minus a, which was 4. So I would split those up, of course, into 0, 4 and 0, -4. Now, I think that was a little redundant to use the formula because we would have just plotted this. So center at 0, 0. Oh, they're counting by 2s again. Oh, why do they hate me? Alright, plotting our major axes, I keep calling it, although I'm sure it's called something else, I always forget. Transverse, there we go, is 4 and -4. So up 4, down 4, and that's the how far up and down this auxiliary rectangle will go. Let's figure out how far over. So that would be with the b value, where are we at? B is 2 units over, so that would, oh, I went too far, over here and here. So I'm going to come back and erase. See, I should have waited to draw in that box until I had all the parts. Good thing I can erase. We'll come back and find the foci in a minute. What I'd like you to do, though, is get in the habit of, after you create the auxiliary rectangle, to draw your diagonal lines through it, which are the asymptote lines. Ooh, I totally forgot to come up with the asymptote lines in the last one. We'll do it on this one. I knew I drew them, but what I really need is I need the equation of the asymptote lines, because that's one of the things. Oh, that wasn't good. They're going to want me to create the equation. Oh, man. Okay. You know, I got so excited about that last hyperbola that I drew like really well. Right? Alright, foci, 0, 0 plus and minus c, which would be like plus and minus, we said it was 4.47, but I'll write 2 square roots of 5 here. So, 4.47 would be, I don't know, like right there maybe? Just remember you're counting by 2s. This set of foci are a little closer to the vertices than the last one because the distances have changed, right? That auxiliary box is more vertical and horizontal this time. So, graphing in our hyperbola now. Oh, that wasn't as good as the last one. That's okay. Oh, that's really bad. Okay. Okay, we're going to have to redo that. In the words of my daughter, this is not my best work. That was not good, guys. I'm sorry. Now, finally, these asymptote lines that I very crudely drew in, I do have to write the equation for them. But the equation is just simply point-slope form with the weird thing in the front here, which is supposed to be the slope, but because of the direction of our hyperbola, the slope for a vertical hyperbola is plus and minus the a over b. And you're going to notice on your formula sheet that it's plus and minus b over a for a horizontal hyperbola. So we have to be careful about this, because that can change. But the h and k are just the center. So for us, that would be y minus 0 equals plus and minus b over a. So instead of 2 over 4, hope you don't mind if I write 1/2. Oh no. Wow, dyslexia. A over b. Gosh, be golly. 4 over 2. That makes a lot more sense, because I was like, that didn't work. There we go. 4 over 2, or 2 over 1. And then x minus 0. Now, technically, that is in true point-slope form. I have no problem with you leaving it like that. I don't think you need to simplify it at all, guys, but if you'd like, because that one's pretty easy to simplify, plus and minus 2x. That would have been the equation of these two dashed asymptote lines that I drew in. Slope of up 2 over 1, slope of down 2 over 1 for the other line. Magical. I know. Alright, this is going to be a horizontal hyperbola with the transverse axis being horizontal. Gosh, I gotta get that vocab down. I keep forgetting that one. Alright, so our a value is 5. And our b value is 6. And this one is on your notes, I believe. Yep, still on our notes. Our center is at 0, 0. That's pretty boring. So what I'm going to do is I'm going to show you how, if this was a homework problem or test problem, what I would do. I'd plot the center, and then I would create the auxiliary box by going 5 units in the horizontal direction this time. And it's kind of my 2's again. You know how I feel about that. I don't like that. Alright. So, I got really angry. Sorry. That's how far out in the horizontal direction, and then 6 units in the vertical direction. So, let's create this auxiliary box. Oh my goodness. Oh. You know, I should get smart. Literally, because this is a smart file, and I have smart tools, and I can draw lines with my smart tools, but maybe during the lesson I'll try that out, during class. Okay, going through the center to the corners here of the auxiliary box. This is what the asymptote lines will look like, and we'll find the equations in a moment. Our vertices are, the formula for the vertices here on a horizontal one are h plus and minus a comma k. So for us, that would be 0 plus and minus 5 comma 0. So that would be at 5, 0, negative 5, 0. So, ba-boom, we're here, and we're here. We already knew that because we plotted the auxiliary box. And then lastly, well, 2 more things. We need to find the foci, which are at, I'm so sorry, h plus and minus c. Ooh, I didn't find c yet, comma k. So let's quick find c. It's the square root of a squared plus, b squared. What is that, 50, 61? I don't know, 7 point something, right? Did I write that down? 7.8 apparently. So, that would be at 0 plus and minus, I'm just going to put 7.8, comma 0. The important thing to notice, though, is right here and right here. Alright, I'm going to graph it in. Oh. You know, after that first one, it's been downhill since then. That didn't get any better. Okay. Yeesh. Alright, one more thing. The asymptote lines. For a horizontal hyperbola, the asymptote line, I'm just going to steal it right off my formula sheet here. It is at point slope form, right? So y minus k, so y minus 0. This one is plus and minus b over a. So plus and minus b over a, so 6 over 5, and then x minus h. So this one is pretty easy to simplify, plus and minus 6/5 x. There we go. Awesome. Oh man, we're gonna have to skedaddle through this lesson real quick, guys. It's more of the same, guys. Let's do one that's not centered. Like this one. This one works. Our center, it's not centered at 0, 0 is what I was going for there. So this center, remember, it's always at HK. So the H is the X value, so -2, 3 is our center. The A value is 5. The B value is 3. And then quickly, let's find the C value, which would be square root of 25 plus 9, so square root of 34, which I think we found that once before, didn't we? Like 5.8 or something? Well, that was the one I had to guess on. It is 5.83 or something. So, I am going to just mark that, I think. So -2, 3 would be right here for my center. And then, this is a vertical hyperbola, so 5 units up and down. Alright, so it's counting by 2s. So 1, 2, 3, 4, 5 will be up here. And then 1, 2, 3, 4, 5 down here. And then 3 units in the horizontal direction. 1, 2, 3. 1, 2, 3. And drawing the auxiliary box in. Oh gosh, big golly, this is ugly. You know what I've learned? Oh boy. I'm gonna need to probably do this lesson at the board and not on a tablet. Alright. Going through the corners. In the center. Oh man, that's ugly. Yeah, it is not good, Abuso. So bad. Alright, let's get these vertices down. We already know where they're at. They're right here and they're right here. But the formula for the vertex, our vertices here, would have been h, k plus and minus the a value. So for us, that would have been -2, 3 plus and minus the a value is 5. So -2, 8. Got it. And -2, -2. Got that one as well. And then focal points, foci, are going to be at h, k plus and minus c. So for us, that would have been -2, 3 plus and minus this weird 5.8, that weird radical. So it's like 8.8, so like just above this. Let me draw them up here and down here. And then, yeah, I'm not going to bother simplifying that, guys. I'm really short on time. I started this lesson kind of late, so my apologies. We might even have to shorten this lesson into two, well, lengthen it, I suppose, into 2 parts. Gosh, that was really ugly, Abruzzo. I don't know what went wrong there, guys, but something did not graph very well. I think it was my asymptote lines I drew. Poor job. Alright, point slope form. Y minus k equals plus and minus. Remember, for vertical, it's a over b. So we're looking at 5 over 3. And then x plus 2. We'll leave it just like that in point slope form. Alright, let's skip ahead and do a completing the square question. This is a little slide that discusses, if you're trying to determine what kind of conic you have, there's clues to look for. You know, if it's a sum problem, it's an ellipse, maybe a circle, you have to kind of investigate that further. You gotta watch out for parabolas too, they get snuck in there. But it's going to be pretty obvious once you start completing the square. So, let's take a look at, let's see, I got 5 minutes. So I'm going to do number 17 and number 19. Okay? In class, hopefully we get through all of them, but let's look at 17 first. First thing I have to do is group my x's together and complete the square. Now I notice there's a common 9. I'm going to need to take that out. So 9x squared plus 6x plus something. And then we're going to do the same thing with the y's. So we're going to group those together. I see a common 4 I'm going to need to take out. So that becomes y squared plus 2y plus something. I'm going to move that 49 over by subtracting it. And then we're going to add this blue number and the red number. Alright, so speaking of the blue number, it would have been a 9 in this quadratic, but this is really an 81 because of that existing 9. And then here, this is a 1, but it's really a 4. So, rewriting this blue term becomes 9 times x plus 3 squared, plus this red term becomes 4 times y plus 1 squared. And then if I add up negative 49, 81, and 4, I'm going to cheat and steal my answer over here. It's a 36. Now the fact that there's coefficients here in front of the quadratic terms tells me it's not going to be a circle, and I have one of the other conics. So I'm going to need to divide everything by a 36, so that way this guy is a 1 over here. I'm going to do it this way though. And then we've done this before, but now we have to watch out for hyperbolas. But I can tell you it's not going to be a hyperbola because this is a plus, right? So this is x plus 3 squared over 4 plus y plus 1 squared over 9 equals 1. So if my job was just to determine what kind of conic it is, and like not necessarily write it pretty, I probably already knew it was an ellipse like way back at this step, because I saw that there were factors taken out and a plus sign in the middle, so ellipse was my answer. But then it wants me to go find the center and everything. I'm going to skip that for a moment, and I'm going to look at number 19. So we're going to do something similar. We're going to complete the square with the x's first. I'm going to take out that common 16. And we get x squared plus, oh, I hope I did this, 6, yeah. The bell's about to ring. Okay, 6x plus something. And then same thing for the y's. Oh my gosh, guys, I already know I have to take out a negative, which means I already know what this is. So spoiler alert, this is a hyperbola. We're going to continue on with the problem though, just because I think we struggled with completing the square a little bit on our last summative, so why not? Alright, this blank is a 9, but it's really a 96, right? No, it's not. It's a 144, yeah. Totally do that. And then this blank is a 16. It's really a negative 16. So, stupid of me to write plus negative, but whatever. Alright, let's clean this up. 16, x plus 3 squared, minus, this is a y minus 4 squared, equals, hope I did that, 16. And then definitely going to be a hyperbola. I would have divided everything here by a 16. And got x plus 3 squared. You can say over 1, so you can keep the format. Minus y minus 4 squared over 16 equals 1. So that definitely would have been a hyperbola. It would have been a horizontal hyperbola. We could have found all that stuff, but I'm out of time. Adios, people. I'm done. Part 2 of the lesson's coming next.